part of a beautiful place with such naturally gifted areas. This natural treasure is so large that we marine biologists have not yet explored all of it. There are millions of species that live in different ecosystems around the ocean. Today, in this episode, we're going to learn about the intertidal and the different zones inside the intertidal. Alright, get ready.
The intertidal zone, also known as the littoral zone, is what the land meets the sea.
Yep.
It is located around the coastline, just as here in La Jolla. When it is in high tide, it is submerged underwater. When it is low tide, it is exposed. Again, this is the place is home to many organisms such as algae and crabs.
Yep.
So the tidal area consists of different zones within itself. In this video, we will be exploring 3 different zones: the supertidal zone, the intertidal, and the subtidal. So we will be looking for creatures that inhabit all these different zones, and we will explain the relationship between the habitat and the organisms.
I got that? Look at that, that's just beautiful. Let's get ready for a deep dive. A su verga! The subtidal area is the first zone we will look at. This area is submerged most of the time and only briefly exposed during extreme low tide areas and full moon events. This zone provides habitat to a large diversity of plants and animals in contrast to the other two zones. It is dominated by red algae and animals such as sea urchins and other small creatures. The subtidal zone is found out there. Right now we're in the intertidal zone, but it's out there. Yeah, I'm not getting in there. What does it look like? Most of the subtidal zones have a soft bottom that is made out of sand. Organisms in this zone generally are not well adapted to periods of dryness and temperature extreme. The subtidal zone might be the most diverse zone out of all. Why? The reason for this is because this zone has the most producers. Producers are animals that make their own energy. They don't rely on consuming other organisms to survive. The most notable difference with this zone is that there is much more marine vegetation, especially seaweed, present. Marine vegetation can grow to much greater sizes than in the other 3 intertidal subregions due to better water coverage. Because the subtidal zone is the one that has the most producers and arguably the zone in the intertidal with the most space, there are more species and more interactions between different species than there would be in the other 2 zones. Because of this also means that there isn't one set food chain or food web that covers the whole subtidal. There could be different or multiple food chains with different interactions along the course of the food chain, thus making a giant food web. One example of a food web that we came up with for the subtitle goes as follows. You will have seaweed serving as the producer at the bottom, creating energy out of photosynthesis. The seaweed would then be eaten by limpets. Limpets would then get eaten by a crab, gull, lobster, or whelk. The crab would then get eaten by the gull. The whelk that eats mussels and the limpets would then get eaten by a lobster. Mussels eats plankton and zooplankton. The plankton gets eaten by the zooplankton. The zooplankton then gets its energy by a prawn. The prawn then gets eaten by a fish, which gets eaten by a gull. Of course, this isn't the only type of food web that exists in the subtidal zone. This is just merely an example of what one could look like. In the subtidal zone, different animals could come in and intervene, making a complicated and dense food web. Since I've been talking about the diversity types of food chains and food webs that are present in the subtidal zone, let me tell you about a type of food chain that not a lot of people are familiar with: the epipelagic food webs. What are epipelagic food webs? These food webs are unique and different from your typical food web. They are food webs that primary production consists of phytoplankton. The reason why I'm covering this is because out of all the intertidal subregions, the subtidal zone would be the only one that would be able to support this type of food web. An example of what this might look like would be having phytoplankton as a producer, getting energy from photosynthesis, then have those be eaten and transfer energy to zooplankton, which would then be eaten by nekton, followed by a larger fish or a bigger predator. Now that I shared to you some of the key points of the subtidal zone, let's move on a little higher and visit Eric in the intertidal zone.
Go. So the intertidal zone can be located in where the high tide and the low tide is, which is in the middle. It can specifically split up in three parts: the high tide, the low tide, and the middle tide. As you see here, these intertidal zones can be found in sandy beaches and other places. And in this location is specifically a rocky shore. In the higher zone, it is only flooded when the tide is high, and organisms in this area include anemones, crabs, isopods, mussels, sea stars, and more. In the mid zone, it is flooded and then uncovered twice a day, which has sponges, snails, sea stars, barnacles, crabs, and mussels living here. Finally, the low zone is generally flooded unless of abnormal tides, and compared to the other zones, unlike the other organisms, the ones living here aren't as adapted to excessive dryness or severe temperature changes. Especially in rocky shores, there can be more diversity, due to that these rocks are covered and uncovered by tidal changes. As said, there is a lot of diversity in these areas. However, many of these organisms living here have to be extremely adaptable to the ocean water half of the day, and the other half being out in the sun. As well, they must be aware from predators including gulls, lizards, otters, etc. Yet, from the serious and harsh weather condition, there is a diverse ecosystem. Depending on the region, there will be different types of organisms due to their ability to adapt in the location. Many of these organisms include algae, periwinkles, barnacles, sea urchins, mussels, crabs, sea stars, sea anemones, sponges, jellyfish, fish, lobster, shrimp, clams, and many more. Again, they all face the same tidal level problems, and in this case, when the tide is low, they will face desiccation. Organisms like mussels, clams, snails, or other animals with shells will climb up or walling itself and using its operculum, which would be the snail, in order to conserve moisture. However, this can be harmful to the organisms that use this to conserve moisture, as they do not exchange gases, which are carbon dioxide and oxygen, and they do not feed. Other organisms like sea urchins face desiccation another way by carving holes inside rocks and take shelter inside them, which allows them to have moisture during the low tide. Another struggle these organisms living here face is the constant wave crashes and strong currents. However, rocks are the solution to this problem. Sea stars, also known as starfish and anemones, have suction cups which protect these organisms to be carried off with the waves. As well, starfish have adapted to its environment with the strong leather-like coat, and also has the anemone with the jelly-flexible body. Mussels also use rocks to help them from being dragged into the ocean. However, unlike sea stars and anemones don't use suction cups. Instead, this creature uses a thread-like substance called byssal threads that help attach onto the rock. Barnacles, like sea stars, have hard shell coverings to protect themselves from these waves. Lastly, another major problem that they face in the intertidal zones are predators, especially gulls, lizards, otters, and foxes. Since these organisms are in open areas, it is more likely for them to be prey. Sea urchins face this problem as the same with wave crashes, with hiding in the crevices they make. Snails also do the same by carving holes or cracks for them to take shelter in. As well, periwinkles and other organisms hide within crevices and nooks to protect themselves from predators.
The last zone we will be talking about is the supertidal zone. So this zone is located between the land and the sea, right? That's why the reason it's called a splash zone. It is occasionally splashed with water since it is above the high tide line. This zone is different from the intertidal and the subtidal because it is rarely submerged with water. The only occasion it would be submerged would be during a high tide or during a storm such as a hurricane. This area of the tidal zone probably has the least amount of organism diversity and abundance. Here, organisms face a great deal of changes. An organism inhabiting the supertidal zone is faced against the occasional, random submergence of their habitat, the exposure to a variety of salinity levels due to exposure to fresh water from rain. They must be able to deal with temperature variations from very hot to very cold, or anything in the middle. Organisms who live in this tidal zone have a different predation challenge than in the other two tidal zones. They are seen as prey by both the terrestrial and the marine predators. One of the challenges that organisms here have to adapt to, and that are most likely the toughest challenge, is being able to withstand a wide variety of unstable conditions. These conditions can be from things such as weather, habitat, or water level changes. One of the problems that comes with all three of these conditions is dealing with the possibility of being left without water, access, or desiccation. There are two ways to deal with this challenge: by climbing up or hiding. The climbing up option basically consists of closing one's shell, for example, a clam closing. The reason for why this is a method is because by climbing up, you are avoiding the loss of water that you do have. Some of the downsides of this option is that by climbing up, then you are eliminating the pass of gases, the release of carbon dioxide, and the absorption of oxygen. The option of hiding basically means moving to an area such as a tide pool or others in order to keep moisture. Sometimes this method may include staying in areas where moisture remains longer, such as crevices in rocks or low spots in soft bottoms. Another challenge could be temperature and salinity changes, which are basically very extreme in this environment. Temperature can vary greatly from 60 to 100 degrees. Normal salinity is about 35 ppt, but in this zone, it can be anywhere from 5 to 30 ppt. Salinity can vary in a range of 20 ppt, and temperature can vary in a range of 40 degrees or more. At times, these two challenging obstacles for organisms in the supertidal zone may vary greatly at a combined time and make bad come to worse. Another obstacle is limited space. Even though the supertidal zone isn't the one out of the three that has the most abundant population, however, there are limited resources. Limited space in the supertidal zone can be because there are not much resources. There is heavy competition for the space where these few resources are most abundant. The splash zone is one of the gateways in the tidal zone that is through where a lot of the energy comes from. The energy that flows from one organism to another and from one tidal level to another is not all generated in the intertidal zone. Most of the energy comes from the supertidal and subtidal zones. Even though there are epipelagic organisms in the intertidal zones, there are also these types of organisms with more abundance in the subtidal zones and more so in the supertidal zone. The supertidal zone is a key player in the energy flow of the entire tidal zone. This is because in the supertidal zone, there are lots of sunny patches where plants can grow freely using photosynthesis, and then the organisms that are able to eat them go in the ocean as well. If an organism that consumes energy from the terrestrial organisms and is then consumed itself in the lower tidal zones, it is contributing greatly to the flow of energy in the tidal zones. The most commonly seen lifestyles in the supertidal zone are epifauna and infauna. Epifauna is a type of organisms that live on the substrate surface. An example of this type of organism seen in the supertidal zone is the buckshot barnacle, living on the sandy substrate of the supertidal. Infauna is a type of organism that live in the substrate. An example of this is a chitin submerged under the sandy substrate of the supertidal zone.
In conclusion, the tidal zone is one of the ecosystems in the marine world that has the most competitiveness and it's the most harshest, so watch out.
Despite the competition, all the
organisms that constitute here. There's still a whole bunch of abundance of diversity and a whole bunch of organisms. So each of the 3 zones that make up the intertidal zone are unique to itself in question of species type and resource availability.
So after that, we're going home, man. Like, maybe check out our next episode. We're checking out Edgewater, so outside.
Big head on the beat. Gucci gang, 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 Gucci gang. Spread their racks on new chain. Love do cocaine. I can't buy me no wetter rain. Rather go and buy ball mains. Gucci gang, 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 Gucci gang. Spent 3 racks on new chain. My love do cocaine. Bitch, I forgot name. I can't buy no wetter rain. Rather go and buy ball mains. Ayy, Gucci gang, Gucci gang, Gucci gang, Gucci gang. My lean costs more than your rent. It do. Your mama still live in the tent. Yeah, still slanging dope in the jets. Me and my grandma take meds.
Wait, try to touch it, wait.
Anemone?
The float? There was a float out here earlier.
Oh, really? Yeah.
You know?
Oh, an octopus, yeah.
Oh, they stick to your finger. Touch it, touch it, touch it.
Oh, what the heck?
Wait, it's just. Hey, wait, come touch this.
Down.
Damn.
What have you got?
If you touch it, it kind of sticks to your finger.
What is it?
I don't know what it is.
Oh, that's called an anemone. Okay, when it's sticking to your finger, it's shooting poisonous harpoons into your flesh.
Oh, that's nice.
True story. Won't hurt you because you're a big animal, but it'll hurt a very small fish or invertebrate that's got a mucus skin. It'll paralyze it, and then it closes up like a Venus flytrap and eats it. Can you say that again for our project?
Record on this.
Yeah, it's a
Record them.
It's a sea anemone. Okay, I'm a tide pool educator. That's what I do here.
Okay.
Up in Laguna, actually. So it's called a sea anemone, and 1, 2, 3. They're invertebrates, of course. They don't have any bones of any kind, no nervous system, no brain really, but they do have sensory cells. And so when you touch it, it's like touching a Venus flytrap. You know, a Venus flytrap does like this. Same thing. It'll close up. And of course, you're big and it's not going to hurt you because your skin is thick and you're a huge animal compared to it. And yeah, go ahead and touch it. So it closes in like this.
Weird, huh?
Takes about 4 hours to digest whatever it's digesting, and then it'll slowly open back up. So basically, if you put your finger in the middle of it, you're putting your finger in its mouth and its butt, because it's the same thing. What goes in must come out. Now, the reason it's got stripes on its tentacles, that's not its natural coloration. It has algae living inside the tentacles, which doesn't harm it, but helps the algae. So it's a sort of a symbiotic relationship.